Today I'm going to talk about a series. It's called Moon Knight. So it's a Marvel series. So the story behind the clip I'm going to show you later is that, so there's a moon god, Egyptian moon god called Khonsu. And then Khonsu have hidden something in a pyramid, but then it's 5,000 years ago. So they're trying to pinpoint that with the stars on the sky, but then they find out they cannot actually find it. So then Khonsu used his god power to turn back time. So in this clip, you will see what constellation they're looking for and how they're trying to find the sky 5,000 years ago. Okay.
So this movie title is Moon Knight?
Yes.
Okay.
Okay. Let's see this clip.
I remember that night. I remember every night.
Khonshu?
I can turn back the night sky.
How?
It will come at a cost, and I cannot do it alone. Still, when the gods in prison tell Mark to free me,
Okay, so the thing is that they're trying to use Orion as sort of a clue to pinpoint where the pyramid is. And then, so let's talk about how they can find this Orion 5,000 years ago. So the first thing that will affect the constellation position is this precession. So every 26,000 years, Earth will go through a precision cycle. Yeah. So now we're here, but like 5,000 years ago, it's here. So if we're pointing at different polaris, you can consider that it's a coordinate change. And it's very, I wouldn't say it's very severe, but it's severe enough that you cannot find the Orion, because every century it will move about 1 degree. So specifically 70 years, you will have 1 degree change. So after 5,000 years, you'll have like almost 8 degrees change. But after 8 degrees, you cannot actually find the Orion at the time you want.
But then, this just shifts everything.
Yes.
Right? So you can still see Orion, right?
Yes, but
but in a different.
In a different position. So 5 years ago, let's say Orion's directly on this pyramid.
Okay.
Somehow. It's not to scale. But when you're trying to find, let's say, the moon god says that you have to be there on March 25th, 7 o'clock, and the Orion will be on the pyramid. But you go there 5,000 years later and you find there's nothing. So, yeah. So that's the first thing you need to consider when you're turning back time 5,000 years. And this precession is also affecting our modern astronomical coordinate system. So we had this equatorial system before we have to change the polaris regularly so that we have a good enough coordinate system. But then now we're using quasars, so we're targeting many points. So now we are not relying on this equinox anymore. We're using a lot of quasars and technology to have this ICRS system. Okay, so the next thing that will actually affect the constellation is proper motion. So, this is our line of sight, and you can see that on the sky we'll just see 2 stars, right? But in reality, these 2 stars can be on different distance, and they're in different galaxies, they're in different clusters, etc. So if they're in different environments, then they may have different gravitational field around them. So they will be dragged to different positions. So after some time, you'll notice that your stars will move to different directions. So these 2 stars will not be there anymore, like this. Okay. But if we actually go to calculate the proper motion of Orion 5,000 years, you'll find, because the region is too big, because the Orion region is like 30 times 30 degrees. So it cannot actually affect the shape too much. So you can see the black stars behind red stars are today Orion we see. But 5,000 years ago, it's just a little bit changed in this star, in that star. And other stars, it's just a little bit. Yeah.
Did you calculate this yourself?
Yes.
Good.
Okay. So if you put back time like long enough that there's no people around, then you may see here is somebody else's work. But like if you push back time to 50,000 years before century, you'll see the Orion have this crossed finger instead of just a big hand. And the arrow is also not as round anymore. Yes. So if anyone asks you what Egyptians think of Orion, it's just the same as what we see today. But before people arrive this planet, I don't know, maybe animals will see that. Dinosaurs will see that, like that. Okay.
It's interesting. Orion looks like it's changing the pose. You know, the
Yes.
changing the arm and then they're skinnier a little bit before.
Yeah. So, but if Khonshu chose a different constellation, then this may change, because some proper motion in other constellation would be more severe, and some would not. So, the problem is Orion. And I also find this small video of ESA. So they're plotting the future of Orion constellation. This is for 45,000 years, and they will start from the Orion we see today. So here, you can see that star go away in 45,000 years, and then it reverses the time back so that the stars will come back. And then it'll go away very quickly if you see 45,000 years in 5 seconds. Okay, and the entire sky will also change a lot if you consider long enough time. So this is the motion of 2 million stars without considering proper motion can change. So the time will be on the right-hand side. So you'll see some stars will be moving quite fast, but some stars will just be there. Okay. So let's say we consider the most impossible way of changing this constellation is that if we born a new star there. So supernova can happen very fast when there's a bunch of interstellar medium that creates a massive star, like 25 solar mass above. And then they will quickly evolve to red supergiant and supernova. Boom, it'll create neutral stars or black hole very fast. But okay, let's start from here. So how many will we found in 5,000 years? So according to this paper, so old paper says that it's roughly 3, so 3 per century, because it considers all the observations we have from other galaxies. But here is they're targeting local environment, so they're only observing OB stars within 1 kiloparsec of the sun. And the local star formation rate is here. Local core collapse supernova rate is there. So after extrapolate this rate to the entire Milky Way, they conclude that it's about half a supernova per century. So if we do some more calculation, we know that we expect to have 25 supernovae in the past 5,000 years. And to have this 25 supernovae is not enough because we don't know when it will happen, and supernova can also fade away. And most of this supernova cannot be really bright. So if we also consider other supernova in other galaxies, most of them will be very, very faint for human eyes to see. So the ancient Egyptians will not document these stars. So let's talk about this 25 supernova. So supernova usually fade away after a few hundred days, depending on the type of it. So for some type, like type 1a, it can lose its magnitude very fast. So let's say so this is normalized. This plot is normalized. So we have to assume the apparent magnitude we have of a supernova. So assume there's a -10 magnitude supernova. The light of a type 1a -10 magnitude supernova can only last for about 240 days. But if we consider like type 2p, that blue line there, it can last for about 930 days. It all depends on the magnitude and the type of the supernova. So it's around this range, 100 days. So if we consider all this, so Orion is roughly 30 times 30 degrees square, right? So it's like 1/44 of the sky. And the probability of having a supernova shining on that night is 5,000 times 365 is all of the days we have in 5,000 years. And 25 times 500 is the days that there will have at least one shining. So the probability is around 0.68%, but then if we times this Orion region, then we'll see that if we actually need to see a supernova near Orion enough, the chance is very, very low. But it's not impossible, it's just very, very low. Yeah. So the conclusion is that so Orion 5,000 years ago is pretty much similar to what we see today, but they probably still need to move the sky back 5,000 years because they need to find the exact position of the pyramid. But if you want to hide something somewhere, just don't forget to note the epoch you're targeting so that people can find it without moving the sky because normal people cannot do it. Okay. So here are the reference and the small English tongue twisters here. I asked ChatGPT to produce this. So because here I discuss a lot about equinox, so I asked him to give me many things about EQ sound or EX sound. So that's the result. So an exquisite equinox equals exceptional equilibrium. So this I should be short and this I should be long, and this is A sound. Okay. Shall we try?
One by one. Do you want to start from here? You can break down A, B, C, D.
An exquisite equinox equal exceptional equilibrium.
Good.
Good, but this is exceptional.
Exceptional.
Yes.
Exceptional.
Okay, let's continue.
And exquisite equinox equals exceptional equilibrium.
Yeah, perfect.
And exquisite equinox equals exceptional equilibrium.
So it's equinox and equilibrium, but other things are good enough.
Exquisite equals essential equilibrium.
Okay, it's good, but it's just all the I sounds sound similar. But that's also a common problem of Mandarin user because we don't have this many different types of I's. Okay.
An exquisite equinox equals exceptional equilibrium.
Yeah.
An exquisite equinox equals exceptional equilibrium.
Good. Yeah.
Exquisite equinox equals exceptional equilibrium.
Yes.
So that equilibrium is also long E.
Yes.
I didn't know. I read it.
I didn't know. It's ChatGPT told me.
Very useful.
You have to check the Cambridge dictionary.
I have checked, but they all sound the same to me. They don't write the sounds for me. I just asked the Cambridge dictionary to say these words, but they all sound similar to me. At least all the I sounds sound similar to me. Okay. Do we start to play Kahoot or we start from questions?
Questions? Any questions? Any questions? 1 point. So go ahead.
I don't understand the need for a god to move the sky 5,000 years back exactly, because we know precession now, so couldn't we just do a coordinate change and then we will know where it was?
Yes, I also think that way, but because they're already there, I guess. Because if they really want to turn back time to where it was 5,000 years ago, to have like 8-degree difference, then they have to be there for like a week. It's not like on that date, right? So other days in that week, they can actually find it at this position. But yeah, I guess it's because they're already there and they're too lazy to wait.
So in the movie, did they know about precession?
No, they just directly moved back time. They didn't think about it.
Okay, but when they move back, does that include the precession? Or?
I'm not quite sure because the movie thing is just very short.
Oh, that's they do.
Yeah, they just they just do that.
Okay.
And it seems that the moon, so you actually can see, I don't want to play it, but you can see the lines here.
Yeah.
I think it's the moon track.
Uh-huh.
So I don't really see the moon track angle change too much. So I'm guessing they are not considering that.
Oh, right.
But I don't know.
So I'm waiting. So okay, suppose you know where was Orion 5,000 years ago, and then how do you know where was the planet from there?
So I think it's like, okay, maybe this will help. So I think it's like when they're there and they can use 3 stars to pinpoint a exact position somewhere. Because this is not to scale, the pyramid can be like super small on the Earth.
Right.
And so I think with enough points, because Orion have some major stars, so they can pinpoint to 1 point, like GPS. Yes, I think that's what they're trying to do with that iPad, but I don't really know the, yeah.
It's tricky, you know. Like,
Yes.
for example, okay, if you want to use Orion to tell future students where is NTHU, how do you do it?
The way that I could think of is there are that you take at least 3 and you say at this position you would measure the star to be at this angle and then this angle and this angle. So you have 3 position angles for the stars, and then if you're at the right position, then you would measure the exact angles. It's like the reverse of a GPS, I think.
Yes.
Oh, okay.
But it's hard to do in real life.
Yeah, you need to be at the position right time, right? Because
Yes.
Orion is moving. So
right,
to see a star in a specified position, you need to be there at the right time of the right year.
Even the day and the hour would
Yes.
measure.
Yeah.
Yes.
So that's not so convenient.
Yes. Ancient Egyptians should know better.
Oh, okay. Oh, interesting. Okay, any other questions, comments? So, I don't know, as long as they don't know precision, maybe they can find the pyramid, I think.
Yes.
They have a way to find it
Yes.
if they do everything correct.
Yes, if they do everything correctly and they calculate the exact time
Right.
early enough.
Okay. If no more question, maybe we go to quiz.
Okay. Do I need to quit this?
Was this movie interesting?
I think it's good, but maybe it's not. Like, don't waste a whole weekend. you can watch it while you're eating or something. It's good enough. Okay. Anyone?
Baldwin?
No, it automatically starts. Do we start again?
Yeah.
Okay.
You all eat it? Okay.
It's just, it was saying to me the code was wrong. Maybe I was too late to into the code.
Well, let's do it again.
Okay, let's do it again.
This is Kahoot.
Let it load.
It's Kahoot, that's why. Oh my god.
It used wrong first.
I'm serious to do that, so.
Kahoot.it. This Kahoot.it only.
It's loading so slow. Okay. Okay, let's start now.
Okay.
So how much has the sky changed in 5,000 years is the title. What causes the shape of constellations to change? Because it's the shape, it's not the position. Yeah.
Oh, okay.
I know.
It's equinox.
Good, we practice together.
Okay. How many days can a supernova with a peak apparent magnitude of -10 remain visible? Okay. Read carefully. Yes, so galactic coordinate system is for everything around the Milky Way. Another one need to read carefully. Yes, it's 26,000 years. Here's 1 0 more. Okay. So how many core collapse supernova we can find in a century? So it's 0.5, but 30 is actually what we had before. Okay. Yes, it's death of massive stars. So center of the Milky Way, there will be a black hole, but it's not from supernova, or it's, people believe it's from supermassive black hole, so it's not from stars. Okay.
So Terry was the number one?
Yes, and
Yes.
Eon is
Eon is second?
yeah.
Good. Did you get everything correct?
Yes.
Did you get everything correct?
No, I think I got the first one wrong.
Okay.
Mhm.
Okay, just tricky. Okay, thank
Okay.
you very much. It was a very good presentation and quiz. Any questions about that quiz? Very good. Okay, good. Okay, maybe we have 5 minutes break and then